and welcome to this masterclass. So it is our great honor to welcome Ralf Baecker in our School of Arts to learn about and discuss his wonderful work. So thank you, Ralf, for exploring the interrelations of art, science, and technology, and in such a original and delicate way, and for taking up time to be here with us. Of course, this event would have not been possible if it weren't for the initiative of gnration, this innovative space for creation and exhibition in our city, in our neighbor city of Braga. If you haven't been there yet, so we can give you like 1,000 reasons to go there. One of them is that they commissioned and are now exhibiting Ralf Baecker's work. So right now the exhibition is called Floating Codes and is comprised of two artworks, Interface 1, which I absolutely love, and A Natural History of Networks. So here goes a big shout out to Luis Fernandes from gnration. He could not be here today, but I'm sure he's thinking about this, and a big shout out to him. Now here at the School of Arts, I want to acknowledge Diogo Tudela's work, since he was the one to organize this session, and to articulate all the details, both with Ralf Baecker and with gnration. Also, he was the one who gave me the honor of presenting this session. And he even called me the mega boss of new media and media theory. So thank you, Diogo. Finally, I'm on my right place. Thank you. And finally, and always a big thank to the production team, who is always really great to work with you. Now, as stated before, Ralf Baecker is a German artist working at the interface of art, science, and technology. Let me read you from his own website. Through installations and machines, Baecker explores fundamental mechanisms of new media and technologies. In his representation and specializations of digital and technological processes, he offers a poetic side behind the surfaces of contemporary image making. At the core of his objects lies the entanglement of virtual with the real, or rather, with the world. With a media archaeological outlook, Ralf Baecker digs into obsolete devices for traces and functions that are still detectable in the technologies today. His work seeks to form a hybrid between contemporary digital methodologies and a material-oriented artist practice. As a result, he understands technology not as a tool, but rather as an epistemological instrument in order to pose elemental questions about a world perceived through technological impressions. Now, yeah, indeed, we conceive of the world by its representation, so they are now mostly digital, so it makes all sense. What is really interesting to me is that this idea of working in the interface. Working in the interface is quite an unstable position, if you ask me. Well, standing in between different realities with distinct and sometimes incompatible communication systems such as art, technology, and science, it is to occupy a space of discontinuity, of passage for improper concepts, hybrid concepts, to be read with a spurious reason, as Plato would put it. Enduring this in-betweenness is to inhabit a chronoscopic time of exposure, following the time conception of Paul Virilio, where each system only knows a part of the other system that is exposed in the interface. The other aspects are not there, they are not existent for the other system. And this space-times includes a matter whose plasticity composes virtual and physical, and is never fully achieved or constant, is forever adapting iteratively. So to create artworks under these conditions, or moreover, embrace these conditions and make them the subject and matter of the artwork, all in the same movement, denotes feeling at ease with complexity. And that is also remarkable. As you can imagine, for someone like me who has been exploring theoretically the bright intersections of art, science, and technology through the concept of interface, looking at Ralf Baecker's artworks, and I have to say that Conversation from 2009 and Interface one for 2016 just really enchant me, So to look at his works is like seeing these ideas and put to action. Is like the effortlessly materialization of my thoughts. It's like seeing the functioning of my brain while thinking about this subject, the functioning of my brain on a good day. All the complexes formed by synapses seem to be transposed to these devices, and we can actually see knowledge on the rising, behavior on occurrence. I am therefore super excited to listen and experience this lecture. Without further ado, the stage is yours, Ralf.
Thank you, Cristina. Thank you very much. Also, thank you to everyone else who was involved into making that possible, especially Diogo, and you already mentioned Luis Fernandez from but thank you very much for the introduction first. What I planned is like and I hope you understand me well, voice-wise, to talk a little bit about my artistic practice, to show you some older and recent projects, and talk a little bit about the context and how they evolve and kind of the thinking processes behind the projects. And I would like to start with something very fundamental. So, and you mentioned the unstable, and for me, the unstable is also the forbidden grounds, and the forbidden grounds to go to the forbidden grounds. I'm going a little bit deeper into the fundamental principles of the digital. So if we think about the digital, we have imagine like this super edgy lines, so like this really hard edges, like a signal going from 0 to 1. But if we look at the signals in the real world, so we look at it through instruments, the engineers, we see that they are not that edgy like the mathematician have or imagined these signals. And further, the engineers saw all these strange things kind of appear when the mathematics of the digital kind of introduced into the real world. So I found it really interesting to see all the strange names for all these symptoms that emerge when the digital kind of transforms into the physical, or the logical transforms into the physical. And I was kind of researching in the history of computation and sort of about like what is that? How to deal with these kind of moments where these signals are not one yet, but also not zero. So they're kind of in between. So when the systems are kind of in an unstable state, when the system, these signals could represent meaningful data in a way, but there's always like these short moments in between the signals where the signals are in a state in between, where they're not settled yet or stable. And Norbert Wiener, one of the inventors or kind of main figures behind cybernetics, called this the time of non-reality. And he calls it like a certain time of non-reality pushed far enough will make any device digital. And Julian Bigelow, also an American cybernetician, I think it's essential to point out that these involves a forbidden ground in between and an agreement never assigned any value whatsoever to that forbidden grounds. And I think like in this birth of cybernetics in the early 40s and 50s, there's kind of like this embedded, like this media has to be stable. We have to prevent it from being there's like a very fragile moment in all these systems, but we have to prevent that these systems become unstable, which kind of the whole, you know, the technology that we use now to communicate, the internet and the whole structures kind of are based on that agreement to never look at these in-between states. And for me, these in-between states as an artist have become like an interesting area to explore. I just skip a few slides. So in a way, so the digital is a kind of the digital procedure is something that has learned or kind of learned to eliminate, to get rid of noise. So that's basically the digital methodology. So like if you have a signal that's kind of a data signal and you have noise and put that on top of each other, you kind of get a noisy signal in the data channel, and through the digital methodology you can get rid of the noise at the end again. And for me, in a way, like this eliminating the noise is kind of means also eliminating matter. So the noise is in the material itself, so in the electromagnetic fluctuations in all matter that we know, and the digital kind of tries to eliminate it or eliminated it. For me, then, like I show like now like a very early project. So there, well, so I came from, I studied computer science, went to art school by accident and stayed there and thought about. So that was a time when a lot of people were thinking about possibilities. How could the digital, the virtual kind of extend into the physical world? And that was like in the early 2000s, that was like a very intense idea to imagine kind of how the digital kind of expands in the physical and or in the real or the world. And to show you like an earlier project which is called Nowhere, which was a cooperation with a German search engine, like a very small search engine, and they asked me to do visualization of their data. And I thought, yeah, I don't want to do another data visualization on a screen. So I was thinking about how can I bring this data that is caused by people searching all over Germany for stuff, how to translate that into something physical, into some kind of sculpture. And I built this CNC machine that kind of takes this data stream and kind of encodes it or kind of writes it in the exhibition space into the material. And so this was not about like creating the sculpture and put the sculpture on the wall. It was just about the process. It was of the process, like this idea of having someone searching for something, and that this search request is immediately kind of inscribed in that physical thing. So there was no nostalgia about like producing a sculpture in the classical meaning. The sculpture is just like a memory that kind of gets written during the exhibition period. So it was sometimes running for 4 weeks, and slowly, like a long-term exposure in photography, like a landscape-like image emerged. So that was like, let's say that was the first step. So going from the digital, from algorithmic thinking, from algorithms into the physical space. And so the next step was, okay, but it's still so far away from that processes and algorithmic structures that I actually was interested in. How could these algorithms kind of extend into the physical and can be perceived in a strange, interesting way? So in a way, I was looking for certain ideas. How could I kind of put myself into these machines and look how kind of all these strange operations are happening, and is it possible to read it? How to visualize these complexities inside these machines? And so I started to look basically at the history of computation and first calculating machines. And because like if you start like with contemporary computational things like silicon microchips, you don't find anything that is perceivable with a human eye. And even though if you zoom in, you don't see much of actions happening. And during that research, I came across Gottfried Wilhelm Leibniz Monologien, and he kind of imagined already, let us pretend that there was a machine which was constructed in such a way as to give rise to thinking, sensing, and having perceptions. You could imagine it expanded in size so that you could go inside it like going into a mill. On this assumption, your tour inside would show you the working parts pushing each other, but never anything which would explain a perception. And so that was a really interesting imagination, kind of going in a machine and see how things work, and to look at these complexities, even though I know that there's nothing to read. Yeah, there's no meaning visible by looking at this digital codes. And there's this famous movie that a lot of people know, and I liked as a kid, like the Tron movie, where kind of this group of people go inside the computer to find the master control program. But also, if you look in the histories of computation, or in this case, this is a jacquard loom, a weaving machine, and the weaving machine has on one side like code that with the patterns, and they feed into the machine and produce a carpet. So for me, that was like the best image of like a large machine where kind of this code is translated into matter in a way, and so on. So I became interested in this. I became interested in mechanical machines, mechanical algorithms like the ones of Heron of Alexandria, already 50 before Christ. I was interested in like very simple mechanisms and ideas, concepts of transmitting information, or like for instance a line, which I think a line is kind of such a simple concept, and a mechanical concept as well, that enables like very as a very elemental concepts. And then there's this important relation between time and space. So let's say if you think about the computer today, it's basically a machine that translates different steps in space, which is code, into time. Yeah, so that's basically a computer translates time into space and space into time, and that's the beauty of the machine itself, and so on. And I started to think about how could such a thing become like a process where kind of a machine that kind of exchanges and translates between time and space become something physical, like a room kind of a room where one could go into and started to sketch certain ideas. And the project then was kind of realized that as a large scale kinetic apparatus which kind of implemented a very simple algorithm that produces kind of very complex algorithmic things. And it's named after a book by a German engineer called Rechnender Raum, which means calculating space or computing space, which refers to also ideas of computer scientific ideas about like a machine that's working different to the machines that we know now, but had like it's basically a machine that translates between time and space in a two-dimensional grid. And so that was a little bit the influence, and these kind of algorithms produce also, you find the patterns that these algorithms produce also in nature, like in seashells, and these algorithms are called cellular automatons, and used widely also for generative music and so on. And basically, like the machine that this thing is equal like to this algorithm. So it's like this algorithm, this code translated into a three-dimensional process. And this is kind of like the notation of the system, like translating the algorithms in mechanical movements that implement this algorithm. And I show a little bit of the video. I think probably the quality is not the best. So if you can also have a look on my website, you find all the videos in higher resolutions, and I guess the experience is a little better. But you see, basically, what you look at is not the result, not so much the result of the computational process. So you look at the pure code, basically, at the machine, at the binary structure that kind of computes usually an image, which in this case the image is in the core, but it's not readable at the outside. It's kind of the process. Okay, one more important thing, like a term that maybe lots of you have already heard, and some of you have also good understanding of it, but just wanted to say a few words about cybernetics. So I mentioned it already before. So cybernetics is one, yeah, like this interdisciplinary field that kind of evolved in the 40s, mainly driven from war technology, like people building self-regulating or self-aiming weapons, or so the First World War and the Second World War, and these kind of concepts of feedback and self-regulating systems kind of became then popular in the 50s and 60s and kind of went in many different disciplines. And the mascot of the cybernetic movement was Ouroboros, like this animal that bites itself in the tail and kind of ends up in an infinite loop of reflex and action. Here you have an overview about the people who were kind of active during that time, or who were involved in the cybernetic movements, and so it's a wide range of people, from anthropologists, Margaret Mead was there, and mathematicians, and sure the most prominent guy, Norbert Wiener, also John von Neumann, who was later involved in building the first computer in the United States, but also was involved in the Manhattan Project, simulating the impact or the particle physics of an atomic bomb or the nuclear bomb. And so that was a really strange community of people who sat together and kind of formulated what technology has become today, or they would kind of introduce these thoughts in many different disciplines. But the main principle is probably feedback, and feedback. So there are these two kinds of feedbacks. One is called the positive feedback, which is usually something like if a system kind of feeds its output to its input, and it starts to excite any more and more until it kind of creates an audio feedback is a good example for that, where you have kind of this catastrophe at the end. And on the other side, you have a negative feedback, which is kind of something to control. For instance, a heating where you set like the temperature to 24 degrees, the system measures, and if it's below 24, the heating keeps on heating. If it reaches 24, it turns off. And so it's kind of a system that creates equilibrium or constant state. Other example for positive feedbacks are a lot of games use this as a principle. So at a certain point, like it saturates into one's pocket, and one person earns more and more money and the other one gets bankrupt. Same, it's also very much of a principle in capitalism, let's say. And on the other side, like you have like a lot of technologies that use control, so in self-balancing mechanisms. And another example of a positive feedback is for sure like the COVID pandemic that we have now, where kind of if there's no negative control in it, that now every state wants to implement or is implementing, if you keep it running freely and add up, and so you have exponential growth and the system grows further and further. On another example for negative feedback is like the centrifugal governor that was part of the steam engine by James Watt. And for sure, it has also its aesthetic moment in popular music or in noise music. And so basically, I would say that also a lot of us, or especially or me, for instance, I'm kind of totally conditioned to feedback as an aesthetic moment, and I think it's also infused in many people of the 20th century, and for sure, like where it emerged, feedback or cybernetics as a used or as a control mechanism is, for instance, in self-guiding rockets and weapons. So it's interesting that, in a way, like a lot of things that artists have used since the 60s in this field of art and technology is actually war technology. And so, in a way, also what I'm trying is like to kind of how to escape a little bit the logic of these kind of systems and explore these systems that have their origin in these fields, for instance. So that was a little bit the excursion into cybernetics. And now this I want to talk a little bit about emergent behavior, which is something that I apply or use in many of my installations, or something that I'm kind of exploring with my machines. And you know, the second piece I showed, like this rechnender Raum, so it's not in a non-emergent machine, I would say, because it has a classical algorithmic structure. And for me, maybe one word about emergence. So in philosophy, system theory, science, and art, emergence occurs when an entity is observed to have properties its parts do not have on their own. Properties or behaviors which emerge only when the parts interact in a wider whole. So a good example of emergent in nature, for instance, like the flocking of birds, so where basically something is happening that is not known by each individual in that group. So it's something that's beyond, or that emerges through the interactions of these many starlings. Another example is, for instance, crystal building mechanisms, or in biology, a lot of phenomena. And if you look, you find like in many fields kind of emergent behavior, if it's on scale, and if you have the same thing, basically the same effect in a time scale, is called self-organization, let's say. But I mentioned before that, you know, like to do that, to research like this emergent behavior. So I try to eliminate the separation between process and display. So when you think about computer art, then usually you have a process, an algorithm that runs on a machine, on a hardware, on silicon or mechanical parts, and then it's displayed somewhere on a screen. It's printed out. It's on a projector or whatever. So there's process and display are something that are separated in a way, and I was interested in how can I create these emergent behaviors, and where, in a way, I kind of merge this process and the display of the process into one process where many elements kind of interact in a certain structure and create or some emergent behavior. And so then for me, the term performance or performativity of a machine became important. Another historical example of such machines is like the homeostat, used so also part of the absurd cybernetic inventions, like a system consisting of many connected agents, and they are able to stabilize the others in a way. So it's they act like many organs that work together to maintain a stable state of the system. So that I show you one quick project, kind of which was working with such an idea, where you had like many agents in the system, and they were kind of communicating through wires, and by that kind of creating some emergent or self-regulating behavior. But I jump right to the next project, which kind of uses similar principles and give you a certain idea about, or start with something about self-organization. So one thing that I mentioned, the noise. A lot of people would consider noise as something that is bad. So it's making prohibits good communication in some cases. It makes images noisy. It looks bad to many people. So it's not harmonic. It's not clean. It's dirty. So that's the understanding of noise. So it's for information system. It's like kind of like the devil. But I think so. I was looking for those for examples where noise or randomness kind of acts as an essential element for organisms or mechanisms. So what you have seen, like with the flocking birds, basically noise is an important central element through these creation of this complex movements of the birds. And I came across like this sentence from this Austrian cybernetician who wrote about self-organization. He said, like, thanks to the small demons in the boxes, only those elements of disruption were selected that increase order in the system. So he put like little cubes with magnets in a little bag and shaped the bag, and they formed through random movement like these structured things. So, and I really was interested in these noise or randomness as some kind of catalyst in order to enable something, to create something new. So not as something disruptive. And also like other examples of Lego bricks in the washing machine. And but the basic idea is noise as a catalyst for change. And I don't show the video that I'm talking now about interface, which is in Braga at Generation at the moment. So maybe you have time to go there and have a look, so that you don't have to look at that video. It's much better to see it in real. But it's basically a system that's based or using self-organization as a central element in order to create a dynamic change process. And the noise in this case is kind of taken from particle incidents that were created from the sun activity. So it's called cosmic rain shower that kind of goes like totally random, basically down on the Earth, and they use like these Geiger tubes to detect these random events and feed it into this machine. I think I skip this and go to the next project, and explain maybe a little bit more about these processes because often you see like you see these complex machines and they look nice, but usually they look like sometimes it's difficult to imagine that there's a lot of experimentation and research and testing and experimenting kind of involved. And I wanted to show this briefly. And this project kind of started with the idea of kind of very similar to look at scientific methodologies over the years, and Alvin Toffler did it nicely in the work Order Out of Chaos from Ilya Pegorina and Isabel Stengers. He said like one of the most highly developed skills in contemporary Western civilization is dissection. It's the split of problems into their smallest possible components. We are good at it. So good, we often forget put the pieces back together again. So this questions a little bit like scientific methodologies where you split up the problem in smaller and smaller and smaller problems, but you forget maybe to see the whole and to put these parts back together to see the whole situation. And I was playing with this ideas, also researching into systems, looking at simple systems that they are very simple if you look at one of them, but if you scale it up, then you have kind of interesting degree of complexity. So this is kind of like a motor that I have prepared with a certain driver so that it's kind of reversing its direction when it kind of hits a hits something, an obstacle. So, and you see, so it's something simple. We can look at it and understand what's happening, and it's kind of easy to understand. And interestingly, sometimes they solve their problem in a way that they don't hit each other anymore, so that they find a position where they are kind of they negotiated kind of a solution of their problem. And I tried many things like working with other connections between them. So this took a long time to explore these ideas. So this is something that started 1 year before exhibiting the final project, trying very different ways of connecting them and so on, and scaling things up and changing speed and intensity and the physical dimensions of the actors to mimic different behaviors. Although sometimes there are really nice things going on in the middle of a project, but they don't. I'm not working for a long time situations, so but they were kind of beautiful or interesting accidents. And I spent actually in my practice, I spent a lot of time doing these kind of experiments, and actually like they are like I like that moments because they offer the biggest moment of freedom or of possibilities. Like when you do that experiments, they are like one project could turn out in 20 different ways, and this is something that I find always very exciting. So that's why I'm really a big fan of experimenting and trying and looking and seeing behaviors. So there's a little bit of the building process. So it's something that we did like with 3 people put together, a lot of serial work and a lot of handcraft work, electronic development to drive the motors, simulating things, imagining situations, turning things around 90 degrees, and so on. Running it for a while, repairing things, and so on. All kind of, for me, or crucial parts of processes that are to take, like if you look at at a ready piece, and there's, at least for me, always like 2 years of research and experimenting connected to it. And show you now a little. That's another concept that I find interesting, which is called like meta materials, which usually is something that you will think of as on a nano scale. But I applied this concept of meta materials for my elements that I build. So meta materials derive their properties not from the properties of the base materials, but from their newly designed structures. So so if you look at one of the motors, and so that the properties don't come from that, but how they are connected, how is the structure built. So this is also very much related to emergent behavior, this concept. I'll show you a brief video.
Right.
Okay, so I also would recommend to have a look at the on the website where you get like a video in a higher resolution. And I would like to show another project which was actually meant to premiere, or it has premiered in Braga, but not in a way I have wished. So I'm talking about actually about a live performance piece that I would have liked or loved to perform at a generation, but I was not able to travel, so we only show a video documentation, which is unfortunately not the same, but I would anyway like to show this process because it's a little bit also a very long developing process of this project, and talk a little bit about this as my last part of this presentation. And so I became interested in certain material processes, in chemical systems, and came across like a metal which is called gallium, which is kind of a mixture of different metals, and it's a liquid metal that can be moved or kind of deformed through electric currents. And so I started with an experiment which was like actually 2 years ago. So and then I didn't do anything like 4 or 3 years ago. I put it, that's interesting, but I don't know what to do with it. So so 2 years later, when the quarantine kind of started, I remembered this experiment and started to recreate it. So so this is related to many ideas about also self-organizing or growing structures. So I had the idea, what if can I make these structures grow in a certain way? Can I train the structures to grow according to its outside, to its environment for an installation? So, and I started to experimenting, read a lot of scientific papers. So there were like very recent papers on these materials from the last 10 years on basically nano actuators moving, using this as engines in a way, and I kind of use this to make the structures, to train the structures and to make them, to control them. And another older experiment, which goes back into the media archaeology again, is like this ideas of gone past who trained, used electrochemical systems as a learning system. So he taught through stimuli electrochemical systems in order to create some kind of brain that would react on certain signals with an output. So he imagined like an electrochemical computer in a way. But that was some thought that was not very efficient, or it kind of lost or did not compete like with models with computers that we know today. But I really always like these kind of strange ideas, technological ideas. And for sure, like there's an influence in this drawings or prints of Robert Flood and the idea of the macrocosm and the microcosm. So there's some art historical interest, let's say. And then, so basically I try to control the system. So I build myself electronic circuits in order to control the voltages in the system and to try to create certain patterns, and started like very engineer, or like a, so started with very technical setups and try to control and to create even preciser movements of the materials. You see there are also many burn marks if you look at it. So there were like really a lot of currents going through and sparks coming out of this thing. So another image, that's the second or third iteration of the experiment to make it even more precise, making creating some kind of thing where I can make good photographs and or videos of the thing. And here, like, so it's getting better and better, the images and the control and so on. And I was able to create some feedback in the system to make it grow even more efficient or faster, until it became some kind of performative setup where I can control or kind of play it like an instrument. So this is kind of the interface of it. So it's a little bit of a different work to the other works, which are installations. So it was like kind of creating kind of a material performance in order to perform with this materials live on stage. And there was a little bit research into these kind of physical or chemical effects of these systems. What is the background? And I read a little bit something that I've written, because that's a little bit more precise than me just talking about it. These processes can be described as a dispersive structure, a term proposed by Ilya Prigorine. A negative entropy flow that exists in an open system that is far away from its equilibrium state. The evolving fractals and structures are the result of an energy exchange between the inside and the outside of the system. As a dissipative structure is characterized by the spontaneous appearance of symmetry breaking, anisotropy, and the formation of complex, sometimes chaotic structures where interacting particles exhibit long-range correlations. These kind of structures appear in different scales, from hurricanes to chemical reactions and living organisms. So basically, this dissipative structures is something that is kind of the underlying principle of emergent systems. I show you a quick video, like a little teaser, and you can see the full video if you are able to get to Braga. So the sound is kind of the result of measuring the currents inside this liquid and kind of translating it into sound. So that's basically like this to build these instrument. So it's all about like there's a lot of doing a lot of work and a lot of considerations kind of to kind of create like this extreme image of these process. So that it kind of becomes a little bit from a physical system, which is kind of happening on stage or something, and to turn it into something that has maybe some kind of raw mixture of something that mixes like in raw aesthetics with computational images. And before I finish, I just want to say like a few more things, which is something that I would address to my students, or that I address to my students regularly, and which is something that I find essential, or in certain ways essential or interesting, or so this is something about that what I teach is something that what I would call a theory and design-driven artistic practice with, about, and through new, but also old technologies and or media. So it's very long, but this is kind of, this sentence shows the complexity also about what a lot of my students or I do, or a lot of other artists do, and who work in that field with technology or scientific aspects and material research, and also and I think like it's kind of like a three-dimensional or multi-dimensional space where on one side there's like design and art processes and experiments kind of is one element, technology and digital programming and materials and coping or controlling materials or not controlling materials, and kind of an theoretical part that also aims a reflection of what we're doing. And all these together kind of creates this mattering, and this mattering something like creating meaning, and at the same time creating a mattering that happens in the now, in the physical. And one to strip it down to seven things, or something I would call some kind of manifesto for practices. Is the first one is like conquer the forbidden grounds in between. So go. I ask, or I encourage people like to go there where the system become unstable, to look not at these ready-made consumer electronics, but kind of open up the things, go there where the systems kind of are weird, are unpredictable, and are strange. And also like celebrate and embrace the noise. So the noise is not the enemy, it's something that supports you, something that constructs, something like a catalyst to generate something new. No noise, no creativity, let's say. Explore and expose the inscribed power structures in technology. So that's something that that's also important, like to look how at the histories of these technologies. So the computer is nothing that fell from, or certain technologies are not really something that just emerged. They have an historical narrative that it's sometimes interesting to look at it, and to give also meaning to things what we do. So we should know that these technologies that we rely on and work on have the origin in the First and Second World War. Dig into the history of technology to find weird, inefficient, and forgotten but poetic solutions. Yeah, that's a little bit like the media archaeological perspective. So look at the technologies that might have been not efficient, but were kind of beautiful, strange, and poetic. Like, I don't know, like the inventions of Gordon Pask that I showed before in the project. Build hybrids of the rational and the magical. So I did not talk too much about this today in order to make it a little bit shorter, but I'm also super interested in magical systems and how they work and how they relate to computational systems. how does like this mystical or magical thinking kind of work against, or is maybe related to this 20th century thinking. And that matter and materials are really like something where everything kind of becomes fluent and vibrant and mattering. And so an experiment and fail. So failing is okay, and failing is fun. And then if you fail, start again and continue and do that in an infinite loop. Yes, so that's it from my side. I hope it was clear, or it was puzzling, or it was confusing, all at the same time. Then I think it was right.
Well, thank you, Ralph. I think definitely it was inspirational, I would say. So there are a lot of ideas that came out of this, and just makes you want to go and start working. So I do, before I just give the audience the opportunity to ask some questions, I would just like to, I don't know, some of the things that intrigued me the most and still intrigue me is this instability that we were talking about, and how do you embrace it? How do you live by it? And the thing that we keep on saying, how is the digital entering the physical world? How will the machine will think? How will it perceive? How will it sense? In a way, we keep on trying to pull the machine to us. It seems to be just this movement on this side. On the other hand, the human being is going also towards the machine. So the way we perceive, the way we sense, the way we think is becoming mechanic, not in a way of being repetitive, but it's just that it's being, well, all the devices that are just some kind of changing our senses and perception of the world. So I would think that when I see your work, I kind of tend to go the other way around, or the other side, make the movement on the other direction.
Yeah, you're totally right. Yeah, sure. The technologies had like an extreme impact on how we think. You know, like they propose the metaphors for our body. So it's not like the machine is kind of imitating more and more us. It's actually the other way around, that we are more and more imitating the machine in order to optimize also the communication with them. Like, you know, like we are basically half Turing machines in a way. So so we are adapting more to the machines than the other way around, I would say. Yeah.
I was also very interested, of course, in the way where you talked about the process and display. They kind of collapse in the same space. They're kind of the same thing, acting in this merging of process and displaying, and that would be somehow what was more interesting to me as an interface person. And how do you think, Ralph? I mean, the way you think is already visually. When you're achieving something like this, when you try to do the same things in the same movement, you have the process and the display. How do you think under this complexity? How do you do that?
But I mean, it's something that has grown. So it's not like that I usually start with very simple things, you know, and then and a lot of things became clearer in looking back. So I was never saying, now I try to merge the display and the process. I did something, and then later I realized, I did that. Okay, that's what I was doing. So so that's actually more my process, that I never do things and analyze things at the same time. So it's always like, yeah, making, like with a certain form of intuition and research and so on, with an intuition, okay, that there's something interesting. And then later looking at and then understanding what really happened and what was actually the thing that I was aiming and so on. And so it sounds always like a super logical thing, like to this presentation, and it was like, oh, how smart is that? But it was always like, you know, looking back and then framing it and then realizing what really happened. So and that's something that I also try to communicate. So it's not often that you know before what you do, what you will what this will exactly be. So you maybe have a rough idea, but you know, at least that's how I understand artistic processes, which are in between, you know, like doing very rational stuff. So I do a lot of engineering, a lot of programming, which is like super rational, logical things. And on the other side, it's like combined with something intuitive, something that I don't really know where it's going, but somehow it's a dialogue between these two things, and then something turns out to a thought that makes sense in the end. Yeah.
Okay, great. So I would now, I still have some more questions, but I'm going to leave some some to the audience. We also have some comments in the YouTube, but that is hard for me to see because I have a delay here. So I would ask the audience, does anyone have a question? I can translate, so you can ask in Portuguese. I think it's not going to be heard by Ralf, so I'll just do the translation.
Can I have a microphone?
Oh, you do have a microphone.
I do have a microphone.
Oh, that's great.
So one of the things I wanted to ask you, and I think I have a kind of a different position that Ralf, I think, expressed in his talk, and also you, Cristina, when he used this quotation, these quotes saying the digital has not only eliminated noise, but matter itself. And when you mentioned that there's a kind of a contemporary vector bringing the digital back to the physical. And I would say that the digital never left the physical. And there's this, I think, this kind of a political problem when we think that immateriality is a affordances of the digital. So I would say that, in my opinion, the particularity of Ralph's work does not reside in the creation of a causality between the digital and the material, but to make such unavoidable entanglement intelligible. And the thing is, because immateriality in the digital is certainly a commonly accepted narrative, it arguably can be traced back to ideas of ideality on mathematics, geometry, and mainly language. But however, I would like to argue that such narrative has no grounding beyond the specific political economic discourse. And one of the examples would be how would such notion encompass the material necessities, and I'm talking about copper or lithium, whatever, in the production of digital devices, and the necropolitics and the soft power, hard power dynamics that it generates throughout the world. So the thing is, like, if we think about the whole idea of lithium back in South America, or the whole dynamics in Congo and Belgium, and how their colonial power was fundamentally in the necessity of extracting copper just to make these devices, if it's safe in terms of the political and others, but let's maybe focus on that now, to talk about materiality in the digital.
Yeah. Thanks for the question. The last bit was a little bit distorted, but I got most of it. Yes, sure. It's either the position of, or the perspective of politics or mathematics. For mathematics, matter, or for computer science, or from the computer science, matter kind of was eliminated. So it does not matter anymore for the logic of these expanding world-spanning systems, you know, and on this perspective of the mathematician. But sure, you mentioned very important aspects, and sure, I'm doing that also to materialize these intangible processes, and you mentioned important things like the geology of media, sort of technology in general, so that these structures are kind of built on material heavy processes of mining and so on. So sure, this is totally connected, but I was in that moment, I was referring to the digital methodology as something that has kind of removed the noise, and so it's, let's say, in a mathematical poetic sense, I meant it. But these perspectives that you are talking about, and I have also some projects about that. That I couldn't show today, are really important, especially like for me through the work of Yuri Parika. We looked at the geology of media and so on.
Okay. So, Ralf, I don't know if I'm seeing this right, because I had never seen the natural history of networks. So this was the first time I saw the work, and it seemed to me that it was, I don't know, in a way, less, how can I put this? So it was more organic, even though the interface, the movements, they are free, there's still the elastic bands that control it. And somehow this one seemed less controllable. Is it, I don't know, is it the way it works? And why did you call it a natural history of networks? Because when I imagine a network, I imagine something more structured.
Yeah. So sure. So for me, it was like I'm always getting also, maybe I was also a little bit bored of working with these kinetic systems. So I did it for a long time, and I became also interested in fluidity as a medium, and kind of creating again the situation between control and non-control and so on. That was something that, and also something that is not, like, if you turn off the system, then it's gone. Something that has an ephemeral effect, so that it's not like something concrete. So that something that if you unplug it, so that it's gone, basically, that it disappears. And something that has a closer relationship to, or like having something that to perform it in a direct moment. So now there is sure a video piece of it, but for me it kind of needs also this moments of a performance of this. And I mean, there are many. I don't want to talk too much about the wider motivation for it, and the title refers to a book by this to a paper by Gordon Pask, who proposes which is called, I think, The Natural History of Networks. But it was kind of like, so it's the kind of a zoom into also microscopic processes, and there are like certain moments where the system kind of, this was only a short excerpt, but where the system kind of produces kind of network-like structures. And even with the actual appearance has not always like quality of a network. There's a network of flows of currencies within the system that kind of that enable it.
Okay. So, does anyone have any other question? No?
We have a question online from Daniel
you.
Laveira. I think this is someone that's trying to hire Ralph's services. He asked, in your work with this kind of algorithms, would it be possible for you to map, for example, choreographical movements? So I think this is an invitation for you to...
choreographical movements,
yeah,
like from
dancing or ballet movements, he said.
I don't know. I mean, it really depends. So in now, like, all systems are kind of they are not programmed to do a certain movement. So they are kind of producing a movement from their inner relationships. So it's not like there's no choreography that tells the machine how to move. There's just a principle that allows, enables the machine to move freely, not freely, but autonomously in a certain range, let's say. And but sure, I don't know. Sure, there's something about different scales where different elements kind of could interact with people. I don't know. I showed this video, not the full video of it, but there was actually some conversation with people being interested to scale things up and to let it interact maybe with people. So there's like reaching a certain scale and then reaching also like the possibility of interacting with humans in a different way.
I think you are hired, I think.
Okay.
Okay. Thank you, Diogo, because here I cannot read the comments. I don't know why. Anyway, so if you don't have any more questions, I think I'm going to wrap up this conversation. And thanking you for your presence here, and the ones that are online, thank you for being there. And especially Ralf, thank you. This was very inspiring, I think, for the students here, for me, definitely. And I thank you also for the pedagogical final part. I think it's super important that you know, summarize it in topics. It really helps. So we couldn't have asked for more. And thank you for being there. And we'll see you around.
Thank you, Christina. Thank you, everyone.